Welcome back to Consumer Math and Personal Finance. Section 1.5.
Evaluate the following expressions. When x equals 3.7, y equals, negative 14.2, and z equals negative 8. Now, in these problems, when it says to evaluate the expressions, basically we replace the variables with their assigned values. So in this problem, I would say 2 times, instead of x, I would replace it by 3.7. And then I would say minus, and instead of z, I would replace z with negative 8. And then I would simplify my expression. So there's nothing inside parentheses for PEMDAS to simplify. So I'm just going to simply multiply here because I multiply first. 2 times 3.7, and that gives me 7.4 minus 8, minus a negative 8. Now minus a negative 8 is the same thing as saying plus a positive 8. Because the signs are the same, we're going to add them and keep that sign, which is positive. So the answer would be 15.4. The next one, I'm going to replace the x again with 3.7. And that's going to get multiplied by the new y, which is negative 14.2, plus 5 times negative 8. And again, 3.7 times negative 14.2, we do multiplication first. And because we're multiplying a positive times a negative, we end up being negative, and we get negative 52.34. No, excuse me, 0.54. And then plus a negative 5 times, or negative 40. 5 times negative 8 is negative 40. I could also rewrite that as just a minus 40. Either way, the signs are the same, so we add them and we keep that sign. So we end up getting a negative 92.54 as our answer for part number 2. Sorry, for problem number 2. On number 3, we're going to have to distribute, but first let's substitute. So we're going to put a 3.7 in place of x, and then in place of y, we've got the negative 14.2 plus 5 times the z, which is negative 8. Now, we can simplify what's in parentheses first. So we can say, or we can distribute. First, I'm going to simplify what's in parentheses with the first part of this. Negative 14.2 and 5 times negative 8 is negative 40. So I can either distribute the 3.7 to everything, or I can simplify what's in parentheses first. I think I'm going to do it that way, so I'm going to end up getting 3.7 times negative 54.2, because I add them together and keep their sign, 54.2. And then 3.7 times negative 54.2 ends up being negative 200.54. Okay, I'm going to switch out the colors here for the next one because I'm running out of space. So, I'm going to replace x with positive 3.7. But I've got to multiply that by a negative, so I'm going to make parentheses here and make that a negative 14.2. And I'm going to turn my parentheses out here into brackets. Plus 5 times, now because I'm multiplying by a negative number, I'm going to put parentheses around that too, so times 8. So when I simplify this, I'm going to simplify what's inside the parentheses here first, the multiplication. So 3.7 times negative 14.2 ends up being negative 52.54. So I'm going to write that. Plus 5. And so I guess that could be a bracket there. Times negative 8. If I finish solving up here, negative 52.54 plus a positive 5 ends up being, again, I subtract them, and I keep the sign of the larger absolute value, so it ends up being negative 47.54 times negative 8. When I multiply those together, I get a positive 380.2. No, not right. 0.32. Point, yeah, 32. Actually, wait. That's neater. Okay, and then if I come to this next one, I start with the y, which is negative 14.2. I divide it by x, which is positive 3.7, and then I subtract negative 8 from all of that. When I simplify this, I can first change this to a plus a positive right here. It just makes it easier to deal with. And then I get negative 14.2 divided by 3.7 is negative 3.837. I'm adding 8 to it. I subtract them because they're different signs to keep the sign of the larger absolute value, which ends up being 4.162. And actually, these are repeating, so I'm going to put lines over them. Now for these next problems, it says to solve the following equations. We're not simplifying expressions, we're trying to figure out what our variable is to make this a true statement. So we're going to kind of go backwards with the order of operations. The idea is to isolate this variable. So the first thing I'm going to do is I'm going to undo what's on the left side because I want to isolate the x. So this is negative 7x minus, negative 7 minus x equals 14. I want to get this negative 7 off of this side. Since it's added to negative x, I'm going to end up doing its additive inverse, which is, I say it's added, but it's a negative 7. So I'm going to add its inverse, which would be positive 7. Whatever I do to one side, I have to do to the other to keep it balanced. So I end up getting negative 8x equals 14 plus 7 is 21. Now, I don't want to know what negative x is. I want to know what positive x is. So I have to undo this. This is the same thing as saying negative x times, negative 1 times x. I want to get rid of that negative, so I'm going to undo the multiplication. So I'm going to divide by that number, because it's an understood one. The coefficient of x is an understood negative 1. And whatever I do to one side, I do to the other. So this ends up being, these negative 1's cancel each other out, so I get x equals negative 21. Now you do not have to go through and show all that work. You can just do that part in your head and just say that negative x equals 21, therefore x equals negative 21. Okay, the next problem, again, we're going to isolate x. This is negative 12 times x. So I have to undo multiplication by its opposite, or by taking, or dividing, I should say. You're also taking the reciprocal, but really would say we're dividing. So if I divide one side by negative 12, I have to divide the other side by negative 12 to keep it balanced. They cancel each other out, and I'm left with just x. A positive divided by a negative equals negative, and when I multiply 88 by negative 12, I actually get a repeating decimal. It's 7.3333 to infinity, so we're just going to call it 7.3 repeating. Okay, the next problem. This is actually easier than the other ones. This is x plus 23. I need to get rid of the 23 so I can isolate the x. So I do the opposite. I'm going to subtract 23 from both sides, keep it balanced, and I end up getting x equals, because they're both the same sign, I'm going to add them and keep that sign, and I get x equals negative 51. Up here, this is x divided by 4.1 equals negative 5.8. So to undo division, I multiply by its reciprocal. Whatever I do to one side, I have to do the same to the other. These cancel. I'm left with x, and negative times a positive is a negative. And when I multiply those two numbers together, I get negative 23.78. And then the last one, this is 2.4 times x, so to undo it, I divide. The same thing as multiplying by the reciprocal. These cancel, I do the same thing to both sides, and I'm left with x equals 18 divided by 2.4 is 7.5. So those are just some quick examples of how to simplify algebraic expressions or evaluate algebraic expressions by substituting numbers in for the variables,